AASHTO classification system. The AASHTO system of soil classification was developed in 1929 as the Public Road Administration classification system. It has undergone several revisions with the different versions proposed by the Committee on the Classification of Materials for Subgrades and Granular Type Roads of the Highway Research Board in 1945. So this is the ASTM designation D3282 or AASHTO method M145. So the AASHTO classification presented in table 5.1. According to the system, the soil is classified into 7 major groups. That is from A1 to A7. Soils classified under group A1, A2, and A3 are granular materials, which 35% or less of the particles pass through number 200 sieve. Soils of which more than 35% pass through the number 200 sieves are classified under group A4, A5, A6, and A7. These soils are mostly silt and clay type materials. Okay, so the classification is based on the following criteria. First is the grain size. So gravel, sand, and silt and clay. Next criteria is plasticity. So the term silty is applied when the fine fractions of the soil have a plasticity index of 10 or less. The term clayey is applied when the fine fractions have a plasticity index of 11 or more. Another classification is if cobbles and boulders are encountered, they are excluded from the portion of the soil sample from which classification is made. So this is the table that we are going to use. So there are 2 general classification, the granular material, and the silt and clay material. So this is when F of 200 is less than 35. Less than or equal. And then this part is if percent passing in sieve 200 is greater than 35%. So these are the group classification that was mentioned from A1, A2, A3, A4, A5, A6, and A-7. So aside from the classification, we also have to evaluate the group index or known as GI. So to evaluate the quality of a soil as a highway subgrade material, one must also incorporate a number called the group index or GI with the groups and the subgroups of the soil. So this index is written in parentheses after the group or the subgroup designation. The group index is given by the equation G's of I is equal to percent passing in sieve 200 minus 35, the quantity multiplied by 0.2 plus 0.005 multiplied by the liquid limit minus 40 plus 0.01 multiplied by the quantity, percent passing in sieve 200 minus 15 multiplied by the quantity plasticity index minus 10. So there are rules to consider in solving for your group index. So first is, if equation 5.1, this is the equation for finding the group index, yields a negative value for GI, it is taken as 0. So if the value is negative, it is taken as 0. Example, the value that was computed for group index is negative 23.5. The value for the group index is 0. Rule number 2, the group index calculated from equation 1 is rounded off to the nearest whole number. So for example, GI 3.4 is rounded off to 3, and then group index 3.5 is rounded off to 4. So take note, whole numbers. No decimal numbers, so it's whole numbers. Rule number 3, there is no upper limit for the group index. Rule number 4, the group index of soils belonging to A-1-A, A-1-B, A-2-4, A-2-5, and A-3 is always 0. So on the table, alright, so if this is the group classification, automatically the GI on these groups and subgroups are 0, always 0. So if the classification is A-3, there is no need to solve for the G's of I because automatically the group index in this group is 0. Rule number 4, when calculating the group index for soils that belongs to group A-2-6 and A-2-7, use the partial group index for PI or this one. So remember, yung first equation natin is kinda lengthy. But for these following groups, A-6 and then A-7, we only use the partial group index. In general, the quality of the performance of a soil as a subgrade material is inversely proportional to the group index. So, standard says that under average conditions of good drainage and the thorough compaction process, the supporting value of a material as subgrade may be assumed as an inverse ratio to the group index. That is, a group index of 0 indicates a good subgrade material, and a group index of 20 or greater indicates a very poor subgrade material. So, subgrade material usually sa highway construction. So, you have the subgrade material, and usually yung subgrade material ay yung mga soil. So, yun ang importance ng group index. So, if the group index is 0, it indicates that the subgrade material is good. And if it is above 20, it indicates that the subgrade material is very poor. So, kapag poor yung subgrade material, it needs thorough compaction and other processes. Okay, example. The results of the particle size analysis of a soil are as follows. Percent passing number 10, or this is your F10, is equal to 100. Percent passing number 40, or F40, is 80. And then percent passing 200 is 58. The liquid limit and the plasticity index of the minus number 40 fraction of the soil are 30 and 10. So, this is your liquid limit. And then this is your PI. Classify the soil by the AASHTO system. So, let's try to classify the soil. So, first step is to check if it is a granular material or if it is a sealed material. So, if it is a granular material, use the upper portion of the table. If F200 is less than or equal to 35%, we use the upper part of the table. If it is silt or clay material, how do we know if it is a silt or clay material? When F200 is greater than 35%, that is silt clay material, we use the lower portion of the table. So, going back to our example, F10 is 100, F of 40% finer at number 40 CF is 80%, finer at number 200 CF is 58, our liquid limit is 30, and our plasticity index is 10. So, first is we have to check if it is a granular material or if it is silt material for us to know where to begin classifying. So, our F200 is equal to 58, which is greater than 35%. So, if it is greater than 35%, therefore, this is silt clay material. We are going to use the lower part of the table. So, let's start classifying from here, A-4. So, ang pag-classify natin, we start to check if the soil meets all the conditions presented in this group A-4, automatically, this will become the group classification of the soil. So, we always start from left to right. Again, kapag nasatisfy lahat ang conditions on this particular group, automatically, this will become the group classification of the soil. Now, if one condition is not satisfied, we move to the next group. So, the condition is lahat ng mga condition dito ay dapat masatisfy. If one is not satisfied, we move to the next group. If the group satisfies all the condition, automatically, yun ang magiging classification ng soil natin. So, let's start for A4. So, it says that for F percent passing in sieve number 200, the minimum value is 36. So, our F200 is 58. So, we satisfy the condition. Next is to check our liquid limit. The value is maximum of 40. Ang liquid limit natin ay 30, which is less than 40, so that is okay. And then, next is plasticity index. The plasticity index has a maximum value of 10, and our plasticity index is 10, so pasok siya, so that is okay. So, meaning to say, we're able to meet all the conditions for A-4, so automatically, this will become the group classification of our soil. So, after getting the group classification, we have to solve for the value of group index. So, using the equation, we substitute group index is equal to our percent passing in sieve number 200 is 58 minus 35 multiplied by 0.2 plus 0.005 times our liquid limit is 30 minus 40 plus 0.01 multiplied by our F200 is 58 minus 15 multiplied by PI, our PI is 10 minus 10. So, automatically, this becomes 0. So, our GI is 3.45 and the rule says that we always have to round off the group index into whole number. So, GI is 3. Therefore, the soil will be classified as A-4-3. So, this is the proper way of writing the answer. So, A-4 is the group classification, and then the GI is placed in an open and closed parenthesis.